Okay, guys. So it looks like a lot of people are struggling with Lab 4.3. So I'm actually gonna walk you guys through it to how I would do it. And I hope this helps you guys understand lofting better and also guidelines better. So let's take a look at 4.3 again. It's the tube one with the two dimensions, two diameters, three diameters, and then you have to follow the path, right? So again, like I mentioned in lab, what I like to start with is the center line right here, right? I choose it because one, that's actually what we have dimensions for. We don't have dimensions for the outside at all, only the center line. So we're gonna start drawing that. And then with the center line, wherever we see one of these lines, we're gonna draw a line there as well because we want planes there to help divide our part, right? So I'm gonna draw lines on my center line and it's gonna help us create the planes that we need. So let's start with the center line. So let's start sketching. And remember the orientation for this one, we have to sketch on the front plane to get the right orientation. So let's just start with a line and then an arc, make it go that direction, line again, oops, line again, right? And then another arc, just go in that direction, and then another line, perfect. And then we're gonna make these construction lines and make them equal. And then I'm gonna make this one and this one equal, right? Save my time with dimensioning. So all these are supposed to be tangent. So let's make all these tangent. And remember to set relations. Click on your first feature, hold control, click on your other feature, and then you can set the relation between the both of them. All right, so all my relations are set. So let's set the dimensions. So top to bottom, this is 8 inches, right? And then and then from the endpoints, it is supposed to be what, 18 inches. All right, let's fix this a little bit before we start dimensioning more. All right, and then this is supposed to be 4 inches. And then I made these equal, right? So they're gonna correspond and be the same diameter. This is also 4 radius. And then again, since these are equals, they're gonna become the same, right? So now everything's fully defined. So now we have this center line finished, right? So again, like I said, wherever I see a line here, I want to make a line because I want a plane there. So let's start doing that. Oop, oop, I think it's lagging a little bit. All right, so let's start, right? First line, second line, and then a line here, a line here, a line here, this line, and then one more line. Perfect. All right. So now I want these at this point, so I'm gonna make them midpoints, right? Make this midpoint, that a midpoint, perfect. And then I want this to be perpendicular, so I'm gonna say perpendicular relation. And then all these are gonna be on the same plane or direction. So I'm gonna do all parallel, right? Now they're all the same way, saves me time. So what I'm gonna do right now, I'm gonna add a point, make that point the midpoint of this line so that I can put this line that I drew perfectly right in the middle. Now that's the midpoint to this line. So now we know this line is perfectly in the center of this line for our 250 dimension. So now we can exit, right? So this is the starting sketch that I have, right? The center line and then a line for each of the dark lines we see on the drawing because I want a plane there. So let's start with our planes, creating planes, right? So what I like to do, find my parallel plane, not front, not top, but it's the right plane. Let's show it so you can see it. And now let's start referencing some geometry. So first reference, right plane. We know this is 4 inches away, so let's put a 4, right? And then the next one I'm gonna do, let's just go in order. So let's go down the path. So next one, let's use plane 1 as a reference, and then we want it to this face. So right now, our plane, right, it has the right bend to it, but it goes the wrong direction. We want to turn it 90 degrees. We want to rotate it, right? So sometimes, again, like I said in lab, you're not always going to get it the first try, right? So that's why it's important that sometimes we have to create planes or new features and use those as references to get our correct plane or feature, right? At the moment, in this case, it's our planes. So we can say check mark to this, right? And now we're going to use this plane to get the correct plane we want. So let's select plane 2, and we just want to rotate it 90 degrees, right? So we can just make it perpendicular, right? And now it has a bend and angle that we want, except it's kind of far away. So what we're gonna do, we're just gonna use a second reference, hit that line again, and now it moves, right? To the area we want. Now we can hit check mark and let's just hide this plane so it's out of our way. So now let's do those two. So reference geometry, let's go plane. First reference, plane 3. And then I want to flip the offset, right? Because I want to go the other way. And I think this is 3 inches away. So let's set 3 inches. Yeah, perfect. It's 3 inches away and I want 2. So in our instances right here, let's just make it 2 instances. Now it saves me time where I don't have to do as many, right? So now the next one, let's just do plane 1 again because I just need a distance, right? I think this should be 8, not 8, probably 10. Yeah, it's 10 because 18, 4 minus 4. Yeah. And then one more plane off of this one, and we know that's 4 inches away, right? So now we have all our planes, right? And you guys can see that how important it was that we had these lines, how much easier it made it to make our planes. In this case, for these ones, we could have selected the line and it makes a plane right there. But I just chose to use distance. I just want to draw the lines to show you guys where the planes need to be. But for more importantly, the lines were more important for these angled ones, right? Because that's how we set the curve for it and the location. So now let's hide a couple of these planes because we don't need to see all of them. They're kind of getting in the way visually. Oop, I didn't hide this one. Hide that one. Perfect. Oop, didn't hide this one. Hide that one. Perfect. All right, now let's sketch on our right plane and start at the top. So right now it's kind of hard for me to see, right? Like there's so many points. I'm not exactly sure which point it's at. So I'm just gonna turn it to the side and angle it. So for myself, I can see it more clearly. So no matter what, since we selected with the right plane, we're always gonna draw on the right plane and it doesn't really matter. So when you angle it, it's just a little helpful for me to see. So the ID for this one is, or the OD, the outer diameter, right? It's 3 inches up here. We can check mark, and we know that these two planes gonna have to have the same diameter. So let's just sketch on plane 1, and let's just convert the entities and bring this over, right? Perfect. So we didn't have to dimension anything because the 3 inches was already on the old one. So now that's over there. Perfect. Now let's just start on this end. Let's start on plane 7. Let's sketch. And again, I'm not really sure. I think it's this one. Yeah, it's that one. So let's sketch a circle, and this one is supposed to be 2 inches, right? So let's make that 2 inches. Cool, check mark, exit sketch. And then the next one would be plane 6 is the one right behind it. And again, convert entities. Let's just bring that over, check mark. Perfect, looks good. Let's exit sketch. And now let's sketch up here. So this is plane 3. Let's sketch. So again, it's kind of hard. I'm just going to turn it. Whoops. Circle. I think it's this one. Yep. And then this should be 2.5. 2.5. Perfect. Exit sketch. Exit sketch. And again, we can go down the line, right? So now number 4. Let's just convert entities. This one. Check mark. Sounds good. Exit sketch. And then plane 5. Sketch. Convert entities. And we're going to hit that circle again. Right? Check mark, sketch, exit sketch. Perfect. So now we have our sketch, right? And see guys, this is the importance of the center lines. The center line, both like the path and the line, because it just helps our placement. It helps us understand where things need to be, right? So the center lines help us make the planes, set the location of the planes, and then also kind of imagine the position of the circles, right? So now what I'm going to do is we could loft this, right? So when it comes to lofting, imagine I cut this circle into 4 quadrants, right? 1, 2, 3, 4, right? So typically in 4 quadrants, you want to pick everything generally in the same area, right? Because again, that line with these green dots, that is like an imaginary guideline where your material is going to follow that path, but it's really just a suggestion, right? Because we can always change it, right? So the reason why we want to keep it kind of on the same line or same plane is because remember when I showed in lab, when you move these points, it rotates your material, right? So imagine you had a line going along that part. Wherever you twist that line, every point on that line of your material has to turn. So you're literally turning your material when you do this. So that's why it is important to put it in the same general area, right? So we can select our features, make sure it's thin, make sure it's going the right direction, not going the right direction. Did I flip it? Whoa. Oops. one direction. Oh, we're gonna change it. 0.250, right? Let's flip it. Okay, so now it's going the right direction, right? Because we drew the outer diameter, the OD. So the pipe thickness, we want it to go inward, right? Because if we go outward, then the OD is following our dimensions on our drawing, which is supposed to be 2 inches, 250, and 300, right? If we made it go outward, then our new diameters would be 250, 3 inch, and 3.5, right? Which is incorrect. So double check, make sure it goes the right way, right? And again, we can click yes, but the problem is, yeah, it's lofted, but again, look at the shape, right? It's so messy. It's so unorganized. It's not refined at all. So this is wrong, right? So that's why we're going to add guidelines. So we're going to make our guidelines next, right? So let's delete that loft, bring our sketches back. So again, this is the importance of the circles, because now let's hide our middle center line and just look at the circles, right? And now look from the front. So now with the circles, we know exactly where the highest point and the lowest point of these circles are, right? So we can perfectly draw a guideline on the top of our part and perfectly on the bottom of our part. And by drawing these circular profiles first before guidelines, it helps us know where the guidelines are supposed to be. And it's also going to help us draw the guidelines a lot, right? So now let's do our guidelines. Let's sketch again, right? Again on the front plane. So now let's draw a line. Also, it's important, guidelines have to be solid lines. Guidelines cannot be center lines because, again, center lines are just suggestions, right? Versus guidelines, they're like an actual drawing. That's why even for any extrusion, right? Remember the example with like the water and the liquid. If it's a center line, it's going to go through. If it's solid, it actually stays. Same thing for guidelines. Even like last lab for the paperclip, everything has to be in a solid line, right? If it's a center line, it's not going to work. So as we can see, this is coincident to this line, right? But if we turn it, it's in the middle. So because we drew on the front plane, and let's show our front plane, it's right here, right? And if we look from the top, it's right in the middle of our circle. So what's happening is that, yeah, it's coincident, but it's coincident in relation to this line, right? So it might not be perfectly on the edge, but is coincident to that plane of the circle. But we actually need it perfectly coincident on that circle. So what can we do instead? We know the diameter of this, right? It's 3 inches. So what we can do is just smart dimension from our center, since we drew from the center line, the radius, which would be 3 divided by 2, 1.5, right? So now if we turn it, we perfectly have our line at the top of our circle. And these points are one coincident touching the edge of our part, which has to be true for guidelines, right? And then it's also, as we know, since it's the radius diameter, the numbers, we know it's exactly where we want it to be, right? So perfect. So now let's do the other side too to double check. So again, we can try our best to put it at the point, and it probably will be at the point. This is just to double check to make sure your work is correct, because we want it to be perfect, right? Otherwise, the guidelines won't work correctly if it's not an even line. And again, we can put lines here, put a line here. And I don't know how perfect it is. It's fine. And then we'll do a line here and do a line here. So as long as it's coincident, right? So what I'm going to do, actually, I'm going to bring back my center line sketch. And then what I'm going to do is use my center line and these lines and just make it parallel. So now I know that it's at the right angle and I don't have to worry about it. And again, since I know what the diameter is, it's 250, I can just make this 125. Oh, whoops, 1.25. And as you can see earlier, it was already like the perfect number, right? It was 1.25, but just to be safe, it doesn't hurt. This takes you about like what, a couple more seconds, and it will help make your part that you know it's correct. So same thing here. This one was 2, right? So this is only going to be 1 inch. And then similarly, this is going to be 1 inch. Cool, and it's already perfect at 1 inch. Nice. All right. Now the next step for us to do would be to make these arcs. So we're just going to draw a couple arcs. We don't really care about stuff right now. We don't care about tangencies that much. We'll put it right now. So we're going to hide our center line again. And then let's make this and this tangent. Let's make this one and this one tangent. And let's make this one and this one tangent. Perfect. So a lot of you guys asked me in lab about this area because as we can see, it's not a perfect blend, right? It's not, we can't make a tangent. If you guys were to make this tangent, like right now, if I try, you're gonna get errors, right? And the reason you're getting that is because you have a difference in diameter here and here, right? So the way the circle works is if you draw a tangent to here, it'll never touch this line, right? If you want to fix it and make it perfectly tangent, what you need to do is make a line this way, right? So let me show you guys. If I make this collinear, right? It's collinear. So you see here how the circle, it goes underneath this line and it doesn't meet, right? If it wanted to be tangent, the tangency would have to be here. It can't be here because this is too far already. So this line would have to be all the way there. So if you guys want to fix this tangency, that's what you have to do. And I believe at the top there are a couple, like one or two. If you want to fix it, you would have to do the tangency just like that. So now to fix that, let's just connect it on one end and not the other end. Make this tangent. Perfect. And now we can set this tangency to be true. Nice. And it's tangent now, right? And if we look here, this is the problem, right? Again, this is where we would have connected before, and there's a space here. It would never be true. It can't be tangent because tangent has to be all the way out here. So we can leave that. And again, the trim tool, trim to closest, perfect. Looks good, right? Looks good. Now we can exit the sketch. Now we have our whole path, right? We have all the sketches we want to build our body with and the guidelines we want it to follow. So now let's loft again. So let's click all our profiles. And again, you want to click it in the same general region. You want it in the same quadrant, same position, right? Similarly, right? Now we can do guide curves. And then remember the selection. So this is closed loop. Closed loop is when your sketch is closed. No gaps, right? No gaps, right? So it's like the circle that we drew, these are closed because the endpoints, they meet up and merge. Versus the next option, it's a line. You can only choose a line that has to have two endpoints, which is typically what guidelines are, right? And this is selection tool, multiple lines that are connected but aren't a given path. This is regions and then single. So we're going to change it to a line selection, hit select, line selection, hit select. And again, remember your guidelines have to be solid lines. I think some of you guys, your guidelines weren't working because it was concentric. I mean, not concentric, sorry. It was construction lines. And that's why you couldn't select it and it wasn't true, right? So I think we have to flip it, go the other way. Perfect, right? Again, so the reason why we have no material here is because of our guidelines. Our guidelines are limiting our drawing to this region only, right? So if your guideline, it says it has to be constrained here, following your body, and has to be constrained in here, it can't go out. So that's why it's not working, right? We can't tell it to go, our material to go out anymore. It has limits. It can only go in. So just flip your direction, and now it's going in the right direction, right? And we can see this is our OD lines that we drew, the 2-inch, and our material goes inward. And then we can hit check mark, and now we have our loft. And that's how lofting works, right? And remember to submit your part in ISO view and then your hidden lines. So the big things to remember your center line for guiding in the beginning is very important. That'll be the normal line. If you did a swept, right? The guideline you're pushing your body through. Remember to have that. Remember to draw lines where you need planes, especially if it's an angled plane. It can get complicated to make planes, but those lines help you a lot. Multiple sketch bodies, guidelines. Remember, they have to touch your edge and they have to be solid lines. No construction lines. Even your contours inside cannot be construction. They have to be solid lines, otherwise it won't work. Solid lines are non-existent. They're only there for you, the programmer, designer, right? But for SolidWorks, to make a part out of, it's not going to work. So this is how we use Loft. I hope that this video helped you guys understand it better. And those of you struggling, now you guys got it. And now I expect all of you to get this one right. Yep. Nice.